If the areas of two similar triangles are equal, prove that they are congruent. First, let's sketch two triangles to help us think through this proof. We'll call the first triangle, triangle ABC, and our second triangle, triangle DEF. We're given, or we already know, that the area of triangle ABC is equal to the area of triangle DEF. We also know that triangle ABC is similar to triangle DEF. We can say that the ratio of side length AB to DE must be equal to the ratio of side length BC over EF is equal to the ratio of AC over DF. We know that this is true because in similar triangles, corresponding sides are all in the same proportion. Something else we can say about similar triangles is the ratio of their area squared is equal to the square of the ratio of their sides. What does that mean? Area of triangle ABC squared over the area of triangle DEF squared is a ratio that's equal to AB squared over DE squared, which is equal to BC squared over EF squared, which is equal to AC squared over DF squared. This statement again is true because these triangles are similar. What we can say now is that the area of triangle ABC squared over the area of triangle DEF squared must be equal to 1. It must be equal to 1 because we were already told that the areas are equal, and anything over itself equals 1. What we have now is the ratio of a side squared over its corresponding side squared must be equal to 1. And we want to take these three side length ratios and set them all equal to 1. AB squared over DE squared equals 1, BC squared over EF squared equals 1, and AC squared over DF squared equals 1. To get rid of this square ratio, we want to take the square root of both sides. On the left, we have AB over DE, and on the right, we still have 1. The square root of 1 is 1. If the ratio of AB to DE equals 1, then side length AB must be equal to side length DE. That's the only way they can have a ratio of 1. We've now proven that side length AB is equal in length to side length DE. We follow the same procedure for our second ratio. Take the square root of both sides, and you have the ratio of BC to EF must be equal to 1. Again, the only way for that to happen is for BC to be equal to EF. This proves that side length BC is equal to side length EF. We do this one more time. Take the square roots of both sides. Our new statement says AC over DF must be equal to 1. That means that AC must be equal to DF. Side length AC is equal in length to DF. We know that these two triangles must be congruent because all of their corresponding sides are equal. They are proven congruent by side, side, side.